Okay, now we're given damped harmonic motion. So we have a restriction on the motion. It has the motion equation y equals e to the negative t times sine of 8 times pi times t. And we're asked to find a graph for this particular equation for t restricted from 0 to 2 pi. Now, the first thing we want to recognize is a characteristic of damped harmonic motion. It's so much like simple harmonic motion, the wave that we're accustomed to. Damped harmonic motion is simply harmonic motion that's been trapped. It's trapped between two graphs. And those graphs are a of t equals the constant k times e raised to the negative ct, and a of t equals negative k times e to the ct. So one's a positive graph, one's a negative graph. Okay, so let's see what this looks like. We'll make a table, and here we have e to the negative t. So c is equal to 1 and k is equal to 1. Okay, so we're going to find values at t equals 0, t equals pi over 2, t equals pi, t equals 3 pi over 2, and then t equals 2 pi. First for e to the negative t, and then negative e to the negative t. Okay, so what is the value? E to the negative t. E to the negative t when t is equal to 0 is 1. Okay. When e is raised to the negative pi over 2, it's 0.208. When it's raised to the negative pi, it's 0.043. Raised to the 3 pi over 2, it's it's 0.009, and raised to the 2 pi, it's 0.002. Now do the same evaluation for the negative e to the negative t. Okay, so let me pause this just to say something. What we have now is a table, and this table is a list of a of t for the positive value and a of t for the negative value. So just like we have in the brackets above, a of t equals positive k e to the negative ct, and then a of t equals negative k e to the negative ct, we have the points that we're going to graph. So we're going to start this graph by graphing those two functions, a of t. Okay, so we go to 0 to 2 pi, and let's see, the tallest we'll go is positive 1, and the lowest is negative 1. Now at 0, we have values. Let's see, here's pi over 2, and 3 pi over 2. When t is equal to 0, e to the negative t is up here at 1, while minus e to the negative t is at negative 1. And then when it's equal to pi over 2, well, we just plot those points and then we connect them together with a smooth curve. And you'll see that we get this upper curve, which is our a of t equals positive e to the negative t, and our lower curve, and that's a of t equals negative e to the negative t. All right, so we're trying to graph the given function at the very top, y equals e to the negative t times the sine of 8 pi times t. Okay, so what we're going to do is take the sine function and we're going to run it in between these two restrictions, these two the upper and lower graph. Okay, so let's run that pi. Now that's the sinusoidal wave. That's the sine function. You know, the sine function starts at 0, 0. Then it goes up at pi over 2. It's at its maximum. Then it comes down to 0 at pi. Then it goes down to its minimum at 3 pi over 2. Then it goes back up to 0 at 2 pi. That's the regular sine function. But this thing's constrained by the upper and lower graph. It has to stay within there. So the higher and the lower, they keep changing as this thing gets squashed closer and closer together as we move from t equals 0 to t equal 2 pi. So just graph positive and negative k times e to the negative ct, which we did here. Then fit inside either the sine function or the cosine function. Now we fit the sine function inside for this one, so it looked like the regular sine function looks like this. It just starts at 0, 0, and it goes up to 1, then it goes down to 0, and then down to negative 1, and then back to 0. Let's draw this sine function. This is a regular y equals sine x function. Graph that. Okay. Or we could use the cosine function if that one applies, and it looks very much like the other, except it starts at 0, 1, and it oscillates from down to negative 1 back up to positive 1. So which one would we use? Which one of those two graphs would we squeeze in between the two upper and lower graph that we did? Well, look at the given equation. It has a sine function in it. It's y equals e to the negative t times sine of 8 times pi times t, which means we're squeezing that sine graph, the sine graph and not the cosine graph, in between the upper and lower graphs.